whether the heat and temperature are same? No, temperature is different from heat. Basically, temperature is a measure of the degree of hotness of an object. In any of the scales, we will be having two important points to remember. One is the melting point, the other one is the boiling point. The relation between the Celsius and Kelvin scale is given by the expression, that is Tk is equal to Tc plus 273.15. The volume of a gas is inversely proportional to the pressure by keeping its temperature constant. Hello everyone, welcome to session 1 of chapter 11, Thermal Properties of Matter. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. Dear children, as the name suggests, thermal properties of matter. In this chapter, we are going to study about how the matter behaves with respect to heat and temperature. So, what are the behavior, the characteristics of matter when it is heated or when the temperature varies, and many more phenomena when the temperature increases or decreases, the matter, how does it act? About all these things we are going to study in this chapter. So to understand more about these things, let us have some basic knowledge about heat and temperature. So what is a heat? Heat, as we all know, is a form of energy. Heat can also be transferred from one body to another body. Then how does this heat get exchanged? The heat can always be transferred from a body of higher temperature to a body of lower temperature. The temperature will get exchanged between these two bodies until they attain equilibrium condition. So basically heat is a form of energy which can be transferred from one body to another body because of the temperature difference. What is the SI unit of heat? It is joule, and it is denoted by capital J, and the CGS unit of heat is calorie. 1 calorie is equal to 4.186 joules. The relation between calorie and the joules in defining heat is 1 calorie is equal to 4.186 joules, and heat is a scalar quantity. Now, what is temperature then? Are they same? Whether the heat and temperature are same? No, temperature is different from heat. Basically, temperature is a measure of the degree of hotness of an object, which means we can measure the heat and we name the term called as temperature. So, to measure temperature, we use a device called thermometer. The word thermometer is very much familiar to all of us. So, this temperature decides the direction of flow of heat, because the temperature defines what is the measure of hotness or what is the measure of heat of any object. So, the direction of flow of heat can be measured because heat always gets transferred from a body of higher temperature to a body of lower temperature, and hence we can say temperature decides the direction of flow of heat, and temperature is a scalar quantity and the unit of temperature is Kelvin. So, the device used to measure the high temperature, very high temperature, is pyrometer. So, pyrometer is a device which we use to find the higher temperature. So, this is the basic difference of heat and temperature. Let us now move on to measurement of this temperature. So, to measure the temperature, we use various scales. So, what are those scales? One is the Celsius scale, Fahrenheit scale, Kelvin scale, and these are the three basic scales which we use to measure the temperature. So, let's now define Celsius scale, what it is. So, Celsius scale is invented by a scientist called Andrew Celsius. So, in this scale, in any of the scales, we will be having two important points to remember. One is the melting point, the other one is the boiling point, or we can also call it as ice point and steam point. And in this Celsius scale, the ice point or the freezing point of water is 0 degrees Celsius. As we all know, the freezing point of water is 0 degrees Celsius and boiling point of water is 100 degrees Celsius. So, here we are talking about Celsius scale. So, in Celsius scale for water, freezing point or the ice point is 0 degrees Celsius. Ice point or freezing point is nothing but the melting point, and the boiling point of water is 100 degrees Celsius. So these ice point and the steam point or melting point or the boiling point or the freezing point and the steam point are also called as the lower and upper fixed point respectively. So this is about the Celsius scale. Let us now move on to Fahrenheit scale. So what is this Fahrenheit scale? What are the values of the upper and lower points respectively? We'll see now. So this scale is invented by the scientist called Gabriel Fahrenheit. In this scale, the fixed point at lower surface, that is the lowest fixed point or the freezing point, is 32 degree Fahrenheit and the upper fixed point is 212 degree Fahrenheit. So there are 180 divisions between the lower fixed point and the upper fixed point. The relation between the Celsius and Fahrenheit scale is given by Tc equals 5 by 9 into Tf minus 32. So what is this Tc? That is temperature on Celsius scale, and Tf is temperature on the Fahrenheit scale. So any of these scales can be converted into the values on another scales by using one particular relation. Before that, let us study about the Kelvin scale as well. Let us discuss about these expressions later. So what is Kelvin scale? This scale was invented by the scientist, that is Lord Kelvin. So in this scale, the lower fixed point, as we all know, is 273.15 Kelvin and the upper fixed point is 373.15 Kelvin, and there are 100 divisions in between these two fixed points, and the relation between the Celsius and Kelvin scale is given by the expression, that is Tk is equal to Tc plus 273.15. Suppose if we have 100 degrees Celsius, we can write in terms of Kelvin. How? By just adding 273. So 100 plus 273, which will give us 373 Kelvin. So 100 degrees Celsius in Kelvin scale, it is 373 Kelvin. So likewise, we can convert any of the values on one scale to the value on the other scale. These are the basics of temperature and the measurement of temperature. Let's now move on to effects of heat. What happens to an object when it gets heated? What are the changes or the effects that we can observe as the body gets heated? When heat energy is supplied to a substance, the following effects we can observe, that is the expansion. So expansion of matter takes place. It may be in solids, liquids as well as in gases, and there is an increase in temperature. As the substance is supplied with heat continuously, the temperature of the substance will increase, and also we can observe the decrease in the density of a substance, and the substance can change its state. Say for example, ice will melt and convert into water as we supply the heat energy, as well as the water from its liquid state will get converted into a vapor state as the heat is supplied continuously. So we can also observe the change in the chemical composition of a substance, and in case of gases, three variables like a volume, pressure and temperature should be studied, but they are dependent on each other. By keeping one of these value constant, the nature of gases are studied by using a set of laws called gas laws. And let us now move on to the gas laws. First one is Boyle's law. What does it state? It states that the volume of a gas is inversely proportional to the pressure by keeping its temperature constant. It can also be written as V is inversely proportional to P, or to take off this proportionality, we need to introduce a constant. So I'll write it as V equals constant divided by P, or by cross multiplying these two, we can write PV is equal to constant. So Boyle's law states that by keeping temperature as a constant value, the volume and pressure are inversely proportional to each other. So what does Charles' law says? So Charles' law states that the volume of given mass of a gas is directly proportional to temperature at constant pressure. So in Charles' law, we can observe that the pressure kept constant and the volume of a gas is directly proportional to temperature. As the temperature increases, volume of gas also will increase, and from this we can write proportionality is replaced by equal, and that there should be a constant introduction in this, and it is V is equal to constant into T, or we can write this relation as this T is multiplied with constant. I can write it in the denominator, which is equal to constant. This is Charles' law. Now, as we all know, volume is inversely proportional to pressure and volume is directly proportional to temperature. These two equations are from Boyle's law and Charles' law. So, together we can write it as PV divided by T is equal to constant. But how? So, here we could write it as P into V is equal to constant, and here also from Charles' law we came to know that V by T is equal to constant. So, combining these two we can write PV by T is equal to constant, and this can be shown that PV by T is equal to mu into R. So, what is this? When T gets multiplied with RHS, we can get the equation PV is equal to mu RT, where mu is the number of moles of a gas and R is the universal gas constant. The value of R is 8.31 joule per mole per Kelvin, and this equation is called as ideal gas equation. PV is equal to nRT can also be written for n moles of gas, and PV is equal to mu RT can also be written for number of moles of gas, where mu is the number of moles, and the gas which obeys ideal gas equation is known as ideal gas. As we have studied, what are the effects of heat? First one was the thermal expansion, which means the substance or the material will get expanded when the temperature increases. So, our next concept is thermal expansion. So, different states of matter expand differently when they are heated. So, the increase in size of a body when the temperature is increased is called as thermal expansion. Because of the increase in temperature, the body size will get increased. Not so large amount, but we can observe a little expansion or a bit expansion because of the rise in temperature, and we will call it as thermal expansion. So, in solids, the thermal expansion can be studied that a solid has a definite shape. When a solid is heated, it expands in its all directions. So, when it gets heated, the length, the breadth, and the height of any body which is having three dimensions will get changed, and hence the length, area and volume all increase on heating a solid. So, there are three types in thermal expansion. First one is linear expansion, area expansion as well as volume expansion. So, what is linear expansion? As the name says, linear means the length. We are considering the criteria length in case of linear expansion. So, the increase in length of a body due to increase in temperature is called as linear expansion. So, what is the expression for coefficient of linear expansion? See, coefficient of linear expansion can be explained as follows. The fractional change in length per degree raise in temperature is called as coefficient of linear expansion. The fractional change in length per degree raise in temperature is called as coefficient of linear expansion, and we can write the expression for this by considering a rod of length L0 and temperature T0. See, here we have a rod whose original length is L0. When it gets heated, as the heat is supplied, the temperature of the rod will increase and we can observe the expansion in length. And this is the change in length, and hence we have denoted it as delta L. The original length of the rod is L0, change in length is delta L. So, the changed length of the rod after it gets heated is L0 plus delta L. I hope the diagram is clear to all of you. So, here we have considered a rod of L0 which is at a temperature T. So, when the temperature increases from T to T plus delta T, the length of the end will also increases from L0 to L0 plus delta L. So, here as we all know, increase in temperature is delta T, change in length or increase in length is delta L, and the fractional expansion in length is delta L divided by L. But fractional change in length is directly proportional to delta T, which means as the temperature increases, length will also increases fractionally. So, the fractional change in length is directly proportional to delta T. So, it can be written as delta L by L is directly proportional to delta T, and delta L by L proportionality can be replaced by a coefficient called alpha L, where alpha L is nothing but the coefficient of linear expansion. So this expression can be written as delta L by L is equal to alpha L into delta T. So here the SI unit of coefficient of linear expansion is per degree Celsius or per Kelvin, because delta L unit is meter, change in length, and in denominator we have length meter, which is equal to alpha L into delta T. It is nothing but Kelvin. So here we are writing the unit for coefficient of linear expansion, which is equal to m divided by m into this Kelvin goes to denominator. So these two will get cancelled. When this transposed to the numerator, we will get per Kelvin. So if you consider Celsius scale, then it will be per degree Celsius. So let's now study about the area expansion. As we all know, when the material gets heated, not only the length will change, the entire shape of the body will get changed. But how? By increasing its temperature, we can observe the expansion in it. So the increase in area of a body due to increase in temperature is called as area expansion. So to understand this area expansion, let's have a diagram here. Here I have considered an object with area A. As the temperature increases, the entire body will expand. A fractional change we can observe in length as well as in its breadth, so that the entire area of the body will get expanded, and it will expand and reach to this dotted line points, and this is called as delta A. Delta A means change in area. So we can observe here we have represented in dotted lines, that is the change in area after the increase of its area when we supply heat to it. So the expression for coefficient of area expansion can be explained like this. The fractional change in area per degree raise in temperature is called as coefficient of area expansion. So consider a substance of area A at temperature T. As the temperature increases from T to T plus delta T, where delta T is change in temperature, the area of the substance also increases from A to A plus delta A. So this is the new area and this is the new temperature. So here we know increase in temperature is delta T, increase in area is delta A, fractional change in area is delta A by A, where delta A is change in area of an object with respect to its original area, which gives us fractional expansion. But the fractional change in area is directly proportional to delta T, because as the temperature increases, the area will also increase. That can be written as delta A by A is directly proportional to delta T, and delta A by A is equal to, proportionality is replaced by a constant called alpha A, where alpha A is a area expansion coefficient or coefficient of area expansion. So here alpha A can also be denoted by a symbol called beta. So beta is equal to delta A divided by A into delta T is the expression for coefficient of area expansion. Here also the unit for this coefficient of area expansion is per Kelvin or per degree Celsius. So now as we have learnt what is the area expansion, linear expansion, let's now move on to the last type of expansion in solids, that is volume expansion. So as we have observed, as the temperature increases or as we supply the heat energy to a substance, it will expand, whether in linear form, area, the length and breadth of a object will also increase, and here we can study about the volume expansion, because a body can also increase its height as the temperature increases. So the increase in volume of a body due to increase in temperature is called as volume expansion. And the expression for coefficient of volume expansion, to understand that, let's understand the diagram. Here V is the volume of an object at temperature T. So as the temperature increases from T to T plus delta T, we can observe the variation in length, breadth as well as the height, so that the entire volume of the object will change. So the expression for coefficient of volume expansion can be explained as the fractional change in volume per degree raise in temperature is called as coefficient of volume expansion. So we can explain this by considering a body of volume V at temperature T. So when the temperature, as I told, increases from T to T plus delta T, the volume of this object will also increase to V plus delta V from V. So here increase in temperature is delta T, increase in volume is delta V. The fractional change in expansion in volume is given by delta V by V. But this fractional change in volume is directly proportional to temperature, and it can be written as delta V by V is directly proportional to delta T, because as I said, delta T is the change in temperature. As the temperature changes, there exists a volume expansion. So the fractional change in volume is directly proportional to delta T. So now this proportional symbol can be replaced by an equals by introducing a constant called alpha V. Alpha V is also denoted as gamma, and that is nothing but coefficient of volume expansion. So delta V by V is equal to alpha V into delta T. So alpha V can now be written as delta V divided by V into delta T is the expression for coefficient of volume expansion, and the SI unit for the coefficient of volume expansion is per Kelvin or per degree Celsius. Here delta V is a term which is related to volume, and V is again volume. The SI units of both these terms will get cancelled, and we remain with delta T. Delta T's SI unit is nothing but the temperature's SI unit, which is nothing but Kelvin. Suppose if we take it in a Kelvin scale. Suppose if it is taken in a Celsius scale, it is degree Celsius. So when it gets transposed to the numerator, it will be per degree Celsius or per Kelvin. So in today's session, we have learnt about the basic concepts of heat and temperature, as well as we have come across the effects of heat, and we have also studied about the effects of heat in solids, that is linear expansion, volume expansion and area expansion, and about the coefficients of expansions respectively. In our upcoming sessions, let's learn about more things regarding thermal properties of matter. Until then, keep learning all of you. Thank you.